Here we are in lesson 4, working with estimating products for multiplication and quotients for division. To begin, we'll warm up by using the whiteboard exchange method. So if you have a whiteboard or a piece of scratch paper, you can write down your responses and then check them as we reveal the answer. Your job today is to write these in standard form. So we have 1 in the 10,000s place, 3 in the thousands place, 7 in the hundreds place, 2 in the tens, and 9 in the ones. So we have 10,000s, thousands, hundreds, tens, and ones. 1, 3, 7, 2, 9. So your answer should say 13,729. So that purple is going to be what's on your whiteboard. Give this one a try. Remember from the previous lesson, if it doesn't mention a place value, you put a 0 as the digit for that place value. In this case, it does not have any ones mentioned, so you should have a 0 in the ones place. We're going to reveal in 3, 2, 1. We have 5 10,000s, 1,000, 2 hundreds, and 6 ones. This time the tens were not mentioned, so make sure you put a 0 in the tens place. Write your answer, and we're going to reveal in 3, 2, 1. Number 4, 3 10,000s, no thousands, 8 hundreds, 5 tens, and 1 1. Keep in mind you can access that place value chart to help you organize your thoughts. We'll reveal in 3, 2, 1. 4 10,000s, 3 tens, and 8 ones. This time it did not mention the thousands or the hundreds place, so you will need 2 0 digits in this answer. Form your response, and we will reveal in 3, 2, 1. Read this one to yourself. Take some time and try and write your response. Two 10,000s, 100, 5 ones. Write it in standard form. Three, two, one. In this section, we're going to work on rounding, similar to what we did yesterday. This time we're rounding to the nearest thousand first. And then to the nearest hundred second. If we are rounding to the thousands place, we have to look to the right. If it is 5 or more, we said that we raised the score. And if it was 4 or less, we let it rest. 8 is more than 5, so we're going to raise the score to 2. and then fill in the remaining place values with zeros. That is how we would round to the thousand place. Now we're going to round to the hundred. So we're looking at this place value. And to the right, the 3 falls into the 4 or less category. So we leave that 8 to rest and fill in the place values with zeros. Rounding to the thousands place. Look to the right. That is 5 or more. So the 1 turns into a 2. And we fill it in with 3 zeros. Now rounding to the hundreds place. We look to the right. 7 is 5 or more. So the 6 has to raise the score. If you raise the 6, it turns into a 7. And fill in those place values with zeros. Try this one. Start by rounding to the thousands place. To round to the thousands, you have to look at the hundreds. That is 4 or less, so it stays. The 3 gets to rest, and we put zeros in those place values. Now round to the hundreds place. Look to the right. A 1 is 4 or less, so the hundreds place gets to stay, and we fill it in with zeros. I'm going to leave the notes in the top right corner, but I'd like you to try this one on your own. Take a few seconds and round it to the thousand place. Now check your work. Now you're going to round this one to the hundreds place. Is it closer to 3,400 or 3,500? Use the strategy from the notes in the top right corner. And check your work. Round this one to the thousands place. Now to the hundreds place. Here's the next one. Start by rounding to the thousands. Now round to the hundreds place. We're rounding to the thousands. The 3 is 4 or less, so the 9 gets to stay at rest, and then these 3 turn into zeros. Rounding to the hundreds. Here's the hundreds place value. To determine how to round, we look to the right. 5 is 5 or more, so we have to round it up. After a 3 comes a 4. Then we fill in the rest of the place values with zeros. Last one of this style. Try these on your own. Round to the 1,000 place value. Check your work. Round to the hundreds place, or to the nearest 100. And check your work. On his 11th birthday, Blake wants to know how many days he has been alive. How can Blake determine this? The problem is Blake does not have a pencil or paper or a calculator, so he wants to estimate how many days he's been alive. Use some mental math strategies to estimate how many days Blake has been alive. Come up with a reason or an explanation that you could use to explain your thinking. This is just an estimate, so there are multiple ways that you could approximate these values. Take some time now to come up with at least one estimate. One fact that you need to have memorized is the number of days in a year. If Blake is 11 years old, how many days are in each year? That's something that we need to know. So there are 365 days in 1 year. You'll use this fact to help you answer the question. You need to have that fact memorized. Here's an estimate that I came up with. He's 11, and this is approximately 400. 365 rounded to the hundreds place would be 400. I know that 11 times 4 is equal to 44. And then I have 2 zeros. I could also round down. If Blake was 10, and there are 365 days in a year, when I multiply by a 10, it shifts the place values, or shifts the decimal, so I need an extra 0. This one was rounded down, so it was an under approximation, and this one is rounded up, so that one is an over approximation. That tells us that Blake is at least 3,650 days old, but no more than 4,400. So he's somewhere in between 3,650 and 4,400 days old. These are not the only two estimates that you could use. You may have estimated that 365 days was about 370 days and used that fact or that rounding. We can calculate the product of 28 and 79 when we have a pencil and paper by using the standard algorithm, which is the method where you stack them and do each place value as its row and then move on to the next row. However, we can use mental math strategies as a way to approximate what the answer should be and as a way to help us identify whether we got the standard algorithm answer correct or if we made a mistake. It's a tool that helps us determine if we are close to the correct answer. So instead of using 28 and 79, we could estimate the product by rounding these values. And it's helpful to round these values to multiples of 10, so that way we can use the strategies from the previous lessons. So I'm going to round 28 to say that it's about 30, and 79 is approximately 80. Using the strategies from the previous lessons, 3 times 8 is 24, and then I still have the 2 zeros, so it should be around or approximately 2,400. It will be slightly less because 28 is less than 30 and 79 is less than 80, but it should be close to 2,400. In the previous lesson, we were able to break these values apart as 3 times 10 and 8 times 10. These gave us the 10 to the second power because there were 2 10s multiplied together, and that told us that we needed 2 zeros in our answer. Let's try looking at this one here. This is approximating. They've rounded this one down to 4,000. Now, if we were rounding to the thousands place, that 5 would tell us that it would round to 5,000. However, if you round this one down and this one went up to 10, 4,000 times 10 would be 40,000. These are approximations. They're estimates, so it's okay that they're not exact. Do you think this is reasonable? Well, when we round one down and the other up, it helps kind of offset some of that rounding. We have one getting smaller and one getting larger, so they kind of work together. Now, if we actually do the standard algorithm here, let's see how reasonable her answer is. We have 4,598 times 7. 7 times 8 is 56. 9 times 7 is 63. Plus 5 more would make 68. 7 times 5 is 35. Plus 6 is 41. 7 times 4 is 28. 28 plus 4 makes 32. So we approximated, or Tara approximated, that it is 40,000, but the actual answer is 32,168. So this may not be the best answer because we have 8,000, approximately 8,000 away. What's another way that Tara could approximate this and get a little bit closer? What if instead she rounds this one up and this one down, or leaves it? Let's say that this one, 4,598, rounds up to 5,000, and we're going to multiply by 7. Well, 5 times 7 is 35, with 3 zeros, is 35,000. That's closer to the correct answer than her approximation. So there are other strategies you can use to get an even more reasonable estimate. Let's look at problem 1 in your workbook. Estimate each product and show your thinking. Now I like the 20 because it's a multiple of 10. So I'm going to leave that one, but I'm going to round the 7,114. This is approximately 7,000 times 20. We can break this apart. This is 7 times 1, 2, 3 separate 10s multiplied together. And this piece is a 2 times a 10. Multiplication has the property called the commutative property, which says the order does not matter. So I can move these things around. I want to multiply the 7 by 2, and then all my 10s at the end. There are 1, 2, 3, 4. Another way you may write this based on the work we did yesterday is 10 to the 4th power, because there are 4 of the 10s multiplied together. 7 times 2 is 14. So this is 14 times 10 to the 4th power, or 14 with 4 zeros. So 140,000 is our approximation. Because I rounded here, I need to use the approximate symbol, not the equal to symbol. So at the end, we can say 7,114 times 20 is approximately 140,000. It's okay to use the equal symbol between this step and this step because these are equal, but we wouldn't want to say that this is equal to this piece because this is the rounded version. That's why the approximation symbol shows up here. I'll show you what that looks like in this next piece. Let's approximate these. We have 1,009 times 51. Use the approximation symbol. (1,009) is about 1,000, and 51 is about 50. Now we're going to work on this piece, so the next steps will be equal to the piece from before. 1,000 is 10 times 10 times 10, and 50 is 5 times 10. This next line is equal to the one above it. So I have a 5, and then I have 1, 2, 3, 4 10s. You can also write that as 5 times 10 to the 4th power, or 5 with 4 zeros behind it. And then we put the comma here where the thousands place is. So this reads 1,009 times 51 is approximately 50,000. This step is rounded to turn it into this step, but then all the ones beneath it are equal to this piece here. Go ahead and try number 3. There are multiple ways in which you can round or approximate, so it may be that yours does not match a person next to you or what I display on the screen, and that's okay. There are multiple correct answers. I'm going to approximate mine as 90. So we have 92 times 396,285. And I'm approximating that as 90. And this one, I'm going to round it all the way up to 400,000. Now this next line is 9 times 10. And I could write this one as 4 times 10 to the 1, 2, 3, 4, 5. So the fifth power. Using the commutative property, I can change the order. I'm going to put the 9 and the 4 together. And then I have a 10 and 5 more 10s. So I can rewrite that as 10 to the 6th power. Well, 9 times 4 is 36. And 36, with 6 zeros behind it, is 36 million. So this one is approximately 36 million. Number 4 asks, which number is the best estimate of 976 times 52? Well, this is approximately 1,000. It's closer to 1,000 than it is to 900. That rounded up. So I'd like to round this one down so they kind of counteract each other. 52 rounded down would be about 50. So 1 times 5 is 5. And then I have 1, 2, 3, 4 zeros behind it. So the closest approximation would be C, 50,000. Now we're going to look at using our approximations for divisions, finding quotients. These are a little bit more tricky. The way that we round is going to be based on what we are dividing by. It's helpful to select something that would be easily divided using our mental math strategies. So I know that 118 is close to 120. But is 120 easily divisible by 7? Let's think about 12. Is 12 a multiple of 7? We have 7, 14, 21, 28, and so on. So 12 or 120 might not be the best choice when rounding here. We may choose instead to round it to 140 because 14 is a multiple of 7. 14 divided by 7 is 2. So 140 divided by 7 would be 20. However, if we wanted to round it to 120, maybe we wouldn't use 7. Maybe we would use a different number. We could round 7 down to 6 because 6, 12, 18, you can see the 12 here is going to be divisible by 6. 12 divided by 6 is 2. And so 120 divided by 6 is 20. When dividing, it's very helpful to find pieces that round that can be easily divisible using those mental math strategies. Let's take a look at this one. If I want to round the first initial value, I could round that to 5,000. But is 5,000 easily divisible by 73? No. Is it easily divisible by 70? Well, multiples of 7 don't make 5 or 50. So we might try something else. We could round this all the way down to 50. And 5,000 divided by 50 could be our approximation. But that's significantly lower than 73. So let's try something different. What if instead we rounded it to 70? Let's think of our multiples of 7. We have 7, 14, 21, 28, 35, 42, 49, 56. Well, that's close to 5,247. We could do the 52 piece, rounded up to 56. Because if we round this one up and this one down, that might make them closer to the actual answer. So we're going to round this to 5,600. Well, 56 divided by 7, that was the 1, 2, 3, 4, 5, 6, 7, 8th one. And there were 2 zeros here, but we divide out a 0. So we still have 1. So it's approximately 80. You could also write it as 4,900 as your approximation, divided by 70. Well, 49 divided by 7, that's the 1, 2, 3, 4, 5, 6, 7th one. And we have 2 zeros, but we're dividing out a 0. So it could round to 70. Here we have 26,215 divided by 56. And they've approximated 26,215 as 56,000 divided by 56. Is this a reasonable approximation? This is not a great approximation because they've rounded 26,000 to 56,000. That's a big jump. So this is not the best way to approximate this. Let's think of a better way to do this approximation. What if instead we rounded 26,000 to 30,000? That's much closer than 56,000. Well, I see this 30 here, and 30 is a multiple of 5 and 6. 5 times 6 makes 30. So I could round this to either 50 or 60. Let's try 60. 30 divided by 6 is 5. Then I had 1, 2, 3 zeros left, but I divide out one of them. So I have 2 zeros here. So this is approximately 500, not 1,000. In your workbook, you have 5, 6, and 7, where you are estimating each quotient and explaining your thinking or demonstrating your thinking. This one, we can say 129 is approximately 120. Now, it doesn't round to 120. It rounds to 130. But we're using 120 because I know that 12 is a multiple of 4. 12 divided by 4 is 3. And then there's a 0 that remains. This one, 35,471 divided by 9. I can change the 9 into a 10. And then round this to 35000. And when I divide by a 10, it shifts the place values or the decimals. So instead of 35,000, it would be 3,500. We're dividing out one of those zeros, or one of those sets of 10. This one, this 64, we may approximate as 60. So let's think of our multiples of 6. Ooh, I see 42, and I see 42 in the front of this 426. So let's round that to 420. Well, 42 divided by 6, that was 1, 2, 3, 4, 5, 6, 7 of them. And then the zeros that are left are going to divide out. So this one is approximately 7. Miss Baker buys 327 hats for students at her school. Each hat costs $18. About how much do the hats cost in total? Show your thinking. This word each is a tricky word in word problems because it could mean multiply or divide. I multiply when the total is unknown, and I divide if I know the total. Miss Baker buys 327 hats and they each cost $18, but I don't know the total cost, so I'm going to multiply. We have 327 times 18. But remember, it says about how much, so we are able to approximate. I'm going to round 327 down to 300, and I'm going to round 18 up to 20. 3 times 2 is 6. And then I have 1, 2, 3 zeros. So about $6,000. It does not ask us to find the actual answer. However, if you did 327 times 18, it would come out to $5,886. So our approximation is very close. Number 9. A runner climbs 1,276 stairs in 11 minutes. Estimate the number of stairs the runner climbs in 1 minute. This is a division question. We know the total stairs, and we know how many minutes it takes, so we're trying to figure out how much they climb each minute. And again, we are estimating. 11 can be rounded down to 10. And 1,276 would round up to 1,300 if we're rounding to the hundreds place. Remember, I made an approximation from this step to this step, but now I'm going to solve this one exactly as it's written. So now I get to use the equal to symbol. 1,300 divided by 10. I get to divide out a 10. So I'm left with 130 stairs each minute. Okay, so why do we estimate? Estimations are helpful in approximating an answer. It's a great strategy for checking our work. It's also a quick way to get close to the actual answer.